Let's take a look at the definition of a linear equation. Alright, a linear equation is an equation in one variable, and we usually use the variable x. And it can be written in the form ax plus b equals 0. A and b are usually just real numbers, and a cannot be equal to 0, because if a was 0, then it'd be 0 times x, and we would not have an x there. So, I'll just write some numbers in here. 2x plus 3 equals 0. That is an example of a linear equation. Notice that the highest power of x, or any power of x here, this is x to the first power, and usually we don't write that 1 there, but we need that for a linear equation. And linear, the reason it's called a linear equation, if you're ever told something is linear, then you should probably think straight. And so if we were to set this up equal, say, to y and graph it, then it would be a straight line. And so our goal usually with linear equations is to solve for x, to get x by itself. And the way that we do that in an equation is by using addition, subtraction, multiplication, division, whatever it takes to get x by itself. Alright, the first thing that we have to do if we have a linear equation, and usually any type of equation, if we have things in parentheses, then we need to look in front of the parentheses to see if there's any type of sign or any type of number that we need to distribute. For example, let's say that I had 4 times x plus 3 minus 10 equals 12. So generally, with a linear equation like this, if I want to solve for x, I need to follow an order of operations. The order of operations that I learned way back when hasn't changed. Alright, parentheses, exponents, multiplication, division, addition, subtraction. So the way that I remember this this order is, please excuse my dear Aunt Sally. And you probably have heard something like that. And so you might want to make up some saying to help you remember that. Parentheses, that means if you can work things inside of parentheses and simplify, you want to go ahead and do that. Then exponents. If you can evaluate exponents, do that. Then multiplication and division. So if you have any multiplication going on, you have any division going on, you need to go ahead and do that. And lastly, addition and subtraction. Alright, so I have parentheses up here, but there's nothing to do inside the parentheses. I can't say that x plus 3 is 3x. It doesn't work like that. Okay, so I had to just leave that like that. There are no exponents. Multiplication and division, I have a number on the outside of this parentheses. And so that means if there's not a sign between the number and something next to it, that means that you're multiplying. And so I have to use the distributive property, which is if you have a number on the outside of a parentheses, then you need to distribute or multiply that number times everything inside the parentheses. So that would be the first thing that I would want to do on this linear equation. Alright, so I'll have 4x, 4 times x is 4x, plus 4 times 3 is 12, and minus 10 equals 12. Alright, the next thing that I need to do is I need to, if I've done all of my multiplication and division, for now anyway, there's nothing to divide, there's nothing to multiply, I need to do addition and subtraction, left to right. You see I have two numbers here. I have a plus 12 and a minus 10. So positive 12, negative 10. They have different signs. So add the two numbers together. Or I'm sorry, subtract, say 12 minus 10, and then keep the sign of the larger number. Alright, but a positive 12 and a negative 10 give you a positive 2. Alright, now I've simplified this linear equation down. My main goal is to get the x by itself. So I need to get the 4x term. I need to get the 4x term by itself. So how do I get the 4x term by itself? I need to get rid of this 2, and it's a positive 2, so I subtract 2. Well, the thing about equations is, if you do something to one side of the equation, you have to do the same thing to the other side of the equation. So that's going to be minus 2, minus 2, so 4x equals 10, divide by 4. Ooh. So let me step back just a second. This is multiplication, 4 times x. The way that you would get the x by itself, since you're multiplying 4 times x, is to divide by 4. Okay? Because if I divided the left side of the equation by 4, 4 divided by 4 is 1. Okay? And that would give me a 1x, and that's what I want. So I divide both sides by 4. So I have x equals 10 divided by 4, or 10/4. Alright? And now if you have a fraction, we don't want to make this a mixed number or a decimal. We would want to leave it as a fraction more than likely. So the way that you can do that is you look and see, can I divide the numerator and the denominator by some number? Okay, and if you notice they're both even numbers, so you can divide the numerator and denominator by 2. So that's going to be 5 over 2. Now, the reason I got this crazy fraction on this one was because I just made the problem up. Usually the first couple you're not going to get any fractions. I say the first couple if it's a test or if it's a homework, generally. Now, I'm not saying that you won't on the test that we take, but that's the main reason why I got a fraction there. It's just because I made it up off the top of my head. Now, the thing about equations, and really with linear equations it's a lot easier than some other types of equations, is that you can always check your answer. Okay? If you take your answer and you go back to where you started the problem. Now, are you required to check linear equations? No, you're not. But if you have the time, you might as well check linear equations. Some types of equations you have to check because the answers that you get may or may not work out with the original equation. So what I want to do is I want to write down my original equation. Alright, and so the answer that I got was x equals 5/2. So what I'm going to do, where I have an x, I'm going to write in a 5/2. So we're going to work some on our fractions here now. So if I got the problem right, if I solve for x and I got the right answer, whenever I simplify this down, I should get the same thing on both sides of the equation. Okay? If I don't, then I messed up. Or there's something wrong with the equation. So let's see. So I want to follow my order of operations. The first thing that I need to do is parentheses. So look at the parentheses. And you see there are two numbers inside the parentheses. There are no variables left. And I can add those two numbers together. Alright, to add those two numbers together though, since one of them is a fraction, you need to get a common denominator. Alright, so if this is in halves, then we want to change 3 into halves as well. And the way that we do that, if you ever want to change a whole number to a fraction, then you just take the whole number and multiply it times the denominator, that common denominator, and that will give you what you put in the numerator. So 3 times 2 is 6. And look, 6/2 or 6 divided by 2 is equal to 3. So I didn't just make that up. I said 3 times 2 and I got 6. Alright, minus 10 equals 12. So now I need to simplify this fraction here. I need to put 5/2 plus 6/2. When adding or subtracting fractions, you never change the denominator. So 5/2 plus 6/2, that's 11/2. I really made my parentheses too big there. You say 5 plus 6, add the numerators, the denominator stays the same. Alright, 4 times 11/2. So when you multiply a number, or even if this was a fraction, if it was over 1 or over something else, make sure you multiply the number times the numerator. If this would have been 4/3, then you'd multiply 4 times the top and 3 times the bottom. But since it's just 4, make sure you multiply 4 times the numerator. So that's 44 over 2 minus 10 equals 12. And now you can divide 44 by 2. 2 will go into 44 22 times. Right, 2 will go into 4 2 times, 2 will go into 4 2 times. Right, and 22 minus 10 is 12. So you see I get 12 equals 12. Since both sides of my equation are equal, that means that I got the problem right. Now, problems with fractions usually take a little bit longer, and I'm sure there's several steps, that you may would skip. I try not to skip many steps, just in case I accidentally lose somebody. All right, so I know that I'm kind of going slow right now. I promise you I'll pick up the pace a little bit. I want you to try this one. Let's say that I had 4x plus 5 equals 29. A real simple problem. Notice there are no parentheses on this one. All I need to do is get the x value by itself. Alright, so with this linear equation, I need to get the x by itself. So to get the x by itself, we need to balance this equation and get the x on one side by itself. Okay, so the way that we do that, since we have a 4x, first let's concentrate on getting 4x by itself. Since I have a plus 5, I say minus 5, minus 5. What I do to one side of the equation, I always have to do to the other. So I get 4x equals 24. Now, since it's 4x, that's 4 times x. To get rid of the 4, I have to divide by 4. Alright, so x equals 24 divided by 4, or 6. One like this you can check really quick. Alright, you take your original equation and plug the x in. Now, when I plug the x in, if you knew nothing about math, if you knew no rules, if I said plug that x in, you'd have 46 right there. But we all know that if you have a number in front of the x, that means 4 times x. So when I plug that in, I'm going to have 4 times 6. So anytime you plug something into an equation, and this is pretty much any type of equation, it's always a good idea to plug it in parentheses. So 4 times 6 plus 5 equals 29. 4 times 6 is 24. Plus 5 equals 29. So 24 plus 5 is 29. 29 equals 29. So since we got the same thing on both sides, we know for sure that we got that right. Now, on your homework and on your tests, instead of just listing the answer, sometimes, especially, I guess it's more of a math thing to say that the solution set is, and then list your, if you have more than one solution, you would list your answers inside these fancy brackets here. So if you were to see this, maybe you're taking a multiple choice test and this is one of the answers, the solution set is 6. That means that x equals 6. It's just a fancy way of saying that. Alright, let's look at another problem real quick. Let's say I had 3 times x minus 7 minus 5x minus 11 equals 14. So if we follow the order of operations, we don't see anything inside parentheses that I can work out. So there's no parentheses, there's no exponents. We do see parentheses that have things on the outside. Now notice there's a 3 in front of this first parentheses, and then look at this second set of parentheses. There's no number here, but there really is a number here because we have a minus in front. So anytime we have a minus in front of a parentheses, then you want to think about that like that's a -1, right? And the way that we simplify, if we have a minus in front of a parentheses, is we distribute that -1 to everything inside the parentheses. Now you may have been taught just to say, okay, well if you have a minus in front of a parentheses, just distribute the negative to everything in the parentheses. And that's fine, but what we're actually doing is we're multiplying everything by -1. That's just to me, that's the easiest way to think about it. Alright, so we do have a 3 on outside of this set of parentheses. We want to make sure that we distribute that. So that's 3x minus 21 minus 5x. So we had -1 times 5x, that's a minus 5x. And then -1 times -11. A negative times a negative is a positive, so it'll be plus 11 equals 14. Alright, so I've distributed everything. Now I need to work on balancing my equation, getting x by itself. But let's look down here. I have two x values down here, and I have two numbers down here, which I usually just call constants. If I say the word constant, I'm talking about a number with no variable. Okay, so I have two variables and I have two constants that are on the left side of the equation. Alright, anytime you have multiple terms that are the same type on one side of an equation and there's no multiplying to do, there's no division to do, there's none of that, no distributing, anything like that, what you want to do is you want to combine like terms. So on the left side of this equation here, you can see I have a positive 3x and a negative 5x. We always have to look at the positive or negative sign in front to help us keep things straight. So it's a very common mistake just to forget about the sign in front, but we're not going to do that. So if I have a positive 3x and a negative 5x, a positive and a negative, I'm going to say, you can say 5x minus 3x is 2x, and then which number is larger? The 5x is, so you take the sign of the larger number. Ever how you work out positives and negatives in your head is fine as long as you get it correct. So some of you may say 3 minus 5 is -2, and so it's going to be -2x. Just ever how that works out for you. Then I have a -21 and a positive 11. That's going to give me a -11. Is that right? No. It's going to give me a -10. Alright, equals 14. Now, once you've combined like terms, you have really nothing else to do other than get the x by itself. So we have to combine those like terms first, though. We don't want to start moving things around the equation too early. And sometimes it would work out, but sometimes it would lead to other errors. Alright, so what I'm going to do, I want to get the -2x term by itself. So I'll say, I had a -10 right here, so I'll say plus 10 plus 10. Alright, and so I have -2x equals 24. Divide by -2, divide by -2. So I have x equals a positive 24 divided by a -2 gives me a -12. Now before I check this, I want to show you something that sometimes gives students problems. And I've noticed this, usually there's a couple students in college algebra that have trouble if I don't have these two terms right here. If you'll look at my cursor, I don't have those two terms in that order. Maybe I have -10 minus 2x equals 14. Now, just because these aren't in the same order, don't get confused and multiply first or divide first. Don't get confused because the constant's coming first. We still want to get this term by itself. And so I still add 10 to both sides. Now for most of you, you're probably thinking, I knew that, it doesn't make a difference. But sometimes, especially if you haven't done math in a while, something like that can confuse you. Another thing that students will commonly forget is on this step right here, if I have a negative 2x, they'll just divide both sides by 2. Okay, and then so they'll get, well, x equals 12. Well, let's make sure that if you do have a negative, that you divide both sides by negative 2. Just a couple of common mistakes that, that students make a lot. Now, we can check this by plugging it back into the original equation. You may be thinking to yourself, well, why don't we just plug it in right here with a negative 2x minus 10 equals 14? Well, what if we made a mistake whenever we were distributing up here? So we need to make sure that we plug that into the original equation and not some form of the equation we have in case we make a mistake. So I'm going to check this. And I have x equals negative 12. Now when I plug in this value for x, I'm going to put it in parentheses every time I plug it in. So I have negative 12 minus 7 and minus 5 times negative 12 minus 11 equals 14. Alright, so I have really two sets of, I guess, big parentheses. If I'm thinking about the order of operations, I want to simplify everything inside of this set of parentheses and then simplify everything inside of this parentheses. Alright, so I have 3 times, it's negative 12 minus 7. So that's going to be negative 19 minus, then 5 times negative 12 is what? So let me back up just a second though. Once you go inside a set of parentheses, once you're in there, then it's kind of like the whole order of operations starts over. So once I'm inside the parentheses, then if there's any multiplication or division to do, I need to go ahead and do that. Alright, so I'm going to just write above this, 5 times negative 12 is negative 60. So I have negative 60 minus 11. Alright, that's going to be negative 71. Alright, so I simplified this set of parentheses. I simplified this set of parentheses. Now I need to do any kind of multiplication or division. I have a number on the outside of this parentheses, so I'm going to say 3 times negative 19. That's going to be negative 57. And you can use your calculator to do that if you need to. And then I have minus negative 71. And we all know that if we have minus a negative, that's plus a positive. But why is that? That's because what I'm doing is I'm actually multiplying a negative 1 times that negative 71. And a negative times a negative is a positive. Alright, and then negative 57 plus 71 is 14. So 14 equals 14. So that means the solution set is negative 12. So we pretty much, if we have linear equations, we go through those same steps. We simplify the algebra or the algebraic expressions on each side by distributing like we need to. Then we want to combine all like terms. Then after that, we want to isolate our variable. We want to get the x by itself and solve. And then if we have enough time, it's always a good idea to check. Now, what if I have x values or variables and constants on both sides of the equation? Well, generally what we do if we have variables and constants on both sides of the equation, or both sides of the equal sign, we want to get our variables on one side and our constants on the other. Now, we don't usually do that until we've simplified the equation. For example, let's say that I had 2 times x minus 3 minus 17 equals 13 minus 3 times x plus 2. So you see, I have constants on both sides of the equation. I'm kind of used to having constants on both sides of the equation, though. Variables on both sides of the equation. And I have some things to distribute on both sides of the equation. So I'm going to distribute this 2 on the left side. That means I'm going to multiply 2 times everything inside the parentheses. I'm going to distribute a negative 3 on the right side to everything inside the parentheses. I can't do it all at once. I just have to take it one step at a time. Alright, so positive 2 times x is 2x. Positive 2 times negative 3 is negative 6. Alright, then I have minus 17. I just bring that down. Equals positive 13. Negative 3 times x is negative 3x. And negative 3 times 2 is negative 6. So I've distributed. Now what I want to do is I want to just work with this side of the equation, the right side, and the left side separately. I want to, first, I'm going to look at the left side of the equation and see are there any like terms. And there are. I have a negative 6 and a negative 17. So 2x, I can put negative 6 minus 17. If we put two negative numbers together, add the numbers, and then it's negative. So that's going to be a negative 23 equals, now on the right side I have two constants as well, 13 minus 6. And 13 minus 6 is 7. Alright, so now I have a variable and a constant on both sides of my equation. So what I want to do now is I want to get my x on one side, I want to get my constant or number on the other side by itself. It does not matter which side you move your x to. It does not matter which side you move your constant to. It's just that one has to go on one side and one has to go on the other. The positive and negatives will work themselves out. Okay? Generally, if I can, I move the x values to the left side. That's just what I've always done. So if you look at this equation, this negative 3x on the right side of the equation, to move that over, use the inverse operation. If this is minus, you use plus. So plus 3x, plus 3x, so 5x minus 23 equals 7. So now I decided to move my x value or my variable to the left side. That means I need to move my constants to the right side. So plus 23, plus 23, so 5x equals 30. Now to get x by itself, I divide both sides by 5. So x equals 6. Alright. I could check that. Again, you don't have to check linear equations, but to save time, I'm not going to check that one. So real quick, see if you can do this one. 4 times 2x plus 1 equals 29 plus 3 times 2x minus 5. Let's take a look at this equation. First, I'm going to distribute my 4 to everything inside the parentheses. So it's going to be 8x plus 4 equals 29 plus, now distribute your positive 3 to everything in the parentheses, 6x minus 15. Alright, so before I start moving things across the equation and balancing things out, we need to look at each side of the equation separately and make sure there aren't any like terms that I can, or see if there are any like terms that I can combine. And you see there are. On the right side, I have a positive 29 and a negative 15. So 29 minus 15 is 14. Alright, now I have constants. I have variables and constants on each side of the equation. I am going to move my variables to the left side and my constants to the right side. Since this is a plus 6x, I say minus 6x to both sides. So that's 2x plus 4 equals 14. Now I'm going to move my constant over to the right side. So that's 2x equals 10. Divide both sides by 2. And I get x equals 5. And you can check that easily by just plugging it back in. Now, let's look back at the original equation. Now, since this is an equation, that means that what we're doing, we want both sides of this equation to equal the same thing if we plug in a value for x. Alright, so what if we were to think about this equation like it was actually two equations? What if I thought about the left side like it was y equals 4 times 2x plus 1, and I thought about the right side like it was y equals 29 plus 3 times 2x minus 5. If I was to think about this problem like that, and I was to graph both sides of the equation, like so, you'll look here, the blue graph, I believe, the blue graph here is 4 times 2x plus 1, and the red graph here is the 29 plus 3 times 2x minus 5. Now I do have y equals for both of these. And this little sub 1 and sub 2 just means it's different equations. Alright, so if I was to look at these two and see where they intersect, alright, it's kind of hard to see right here, but if we look at this table right here where they have the same y value, that's where they intersect. It's actually, it's right around in here, or here where y equals 44. Look what x equals, 5. And that's the answer that we got, x equals 5. Okay, so there are lots of ways you can think about equations, and that's just kind of a little different way outside the box to think about a linear equation. Is just imagine that each side was its own equation, and we want to know where are they equal. All right, if we made both of these, y equals. Well, where are the y's equal now? Well, it's when the y's would both be 44, and x would have to be 5. So kind of a little neat way to think about that. All right, now for more of the bad word, fractions. Hopefully it's not too bad. Let's look at linear equations with fractions. All right, before I actually look at a linear equation with fractions, let's just look at some constants, meaning terms without variables, with fractions. So, you know, I'd be willing to bet probably the most famous, not most famous, most commonly used fraction will probably be 1/2. If you've ever followed any recipes, usually it's a half a cup of something. Or maybe I need 2 cups of sugar to put in my tea, but I only have a measuring cup that's 1/2. Okay? Well, so then, whether you think about it or not, some of you probably just automatically, if you need 2 cups of sugar and you have a measuring cup that's 1/2, just put 4 scoops of that 1/2. Your brain has gotten used to fractions, at least that fraction, so much that it actually just, you don't even have to think about it. Okay? And so why is that? Well, I don't know why that is, but I do know that once I start changing denominators from 1/2, say, to 1/10, then your brain may not be able to do much of that, or much with that. Or, 3/7. How do I know? Is this larger or is this larger? Is this larger or is this larger? Well, it depends on the total parts that you have. That's the denominator. That's the total possible parts. And then the numerator is how many of those parts that you have. Okay? A lot of times when you deal with fractions and equations, the easiest thing to do is to get rid of the fractions. Now that doesn't mean just take your eraser and erase the denominators, erase all the fractions. Unluckily, or I'm glad that it doesn't work that way. Some of you probably wish that it did. But one way to get rid of denominators, which gets rid of fractions, is by multiplying the entire equation by a least common denominator. All right, so least common denominator. And what a least common denominator will do for you, if you multiply the entire equation by that, is it will get rid of the fractions. Once you get rid of the fractions, then it's just a problem like we worked previously. Okay? For example, let's say that I had x plus 2 over 4 minus x minus 1 over 3 equals 2. Now, there are lots of more complicated and more time-consuming ways to work this problem than I'm going to show you. But being a mathematician, us mathematicians like to always look for shortcuts, and we want to do it the easiest way possible. And so the way that I can get rid of these fractions or get rid of these denominators is by multiplying the entire equation. So I think about this entire equation like it's something that I'm going to multiply a number times. All right, and so what we need to do is we need to look at all of the denominators. We have a denominator of 4, a denominator of 3, and a denominator of 1. If we don't have a denominator, we just think about it like it's a 1. All right, so what we want to do is we want to think, what is the smallest number that I can divide 4, 3, and 1 into? Now, sometimes all you have to do to get the least common denominator is multiply your denominators together. It doesn't always work like that, depending on what numbers you have, but if you were to think what is the smallest number I can divide 4 and 3 into, that would be 12. All right. So what you want to do is we want to multiply this entire equation by 12. All right. Now, I'm going to write this out completely this time without skipping any steps, but some of you will probably catch on to this and be able to skip steps. So we want to think about this like I'm saying 12 times this first term, so it's like 12 times x plus 2 over 4 minus 12 times x minus 1 over 3 equals 12 times 2. It is a very common mistake for students to forget to multiply both sides of the equation by 12. It would be very easy for me just to write a 2 on this right side of the equation and forget. Another common mistake, sometimes students will not put parentheses if they're going to write a number in front. Okay? Now, the reason why I said some of you will probably skip some of the steps that I'm doing, what you can do, you see, when I get right here, I have 12 over 4. So 12 divided by 4 is 3 times x plus 2. Okay. Then I have minus, that's important, 12 divided by 3 is 4 times x minus 1. All right, and then 12 times 2 is 24. And here is the step, that's the step some of you might want to skip if you're good at doing mental math. And what I mean by that is, let's look here where I have the original equation. Everybody look up here where I have the original equation. You can just say 12 divided by 4 is 3, and say 3 times the numerator, like I have right here. And then minus 12 divided by 3 is 4 times the numerator. And then 12 times 2 is 24. If you have trouble with mental math, though, you may just want to do it step by step so that you don't make any mistakes. Students sometimes ask, will these numbers always cancel out? Will I always be able to say 12 divided by 4 and 12 divided by 3? Yes, you will always get rid of the fractions. If you get down to this step here and you still have a fraction, then you messed up somewhere. So now this problem is just like the previous problems, right? I need to distribute. So that's 3x plus 6. Then notice I'm distributing a negative 4. So it's going to be minus 4x plus 4 equals 24. Now simplify each side of the equation. I can simplify the left side because I have like terms. I have a minus x, right? 3x minus 4x is minus 1x, and then plus 10 equals 24. It's very important that I leave that minus there, okay? Because if I don't, it's going to cause some problems at the end. All right, and so I say minus 10, minus 10. So negative x equals a positive 14. And then I don't want to know what negative x equals to. That's actually a negative 1x. I want to know what 1x equals to. So to make that a positive 1x, I divide both sides by negative 1. So x equals 14 divided by negative 1 is negative 14. Alright, so if I have fractions in my linear equations, I need to figure out a common denominator. The actual least common denominator is the best. The smallest number that you can divide all of the denominators into, and then multiply that number times the entire equation. That will get rid of the fractions. And then you can solve for x by doing whatever math steps that you have to. Alright, so let's take a look at this linear equation with fractions. So look at all of the denominators. We have a 4, a 14, and a 7. And we want to find the smallest number we can divide all three of those numbers into. Alright, so that would be 28. Right, you can divide 4 into 28, 14 into 28, and 7 into 28. So I want to say 28 times each term here. So I have 28 times x minus 3 over 4 equals 28 times 5 over 14 minus 28 times x plus 5 over 7. Now some of you may want to do like I did last time and just divide by the denominator first on each one. But again, I don't like to skip steps if it doesn't slow me down too much. So 28 divided by 4, that's 7 times x minus 3 equals 28 divided by 14 is 2 times 5 minus 28 divided by 7, so it's going to be minus, don't forget that minus sign, that's important, 4 times x plus 5. Alright, so now I've gotten rid of all the fractions. So now let's distribute. So I'm going to say 7 times x, 7 times negative 3. 2 times 5 is 10. And then make sure you distribute a negative 4, not just 4. So it's minus 4x minus 20. So 7x minus 21 equals, I notice that I have two like terms. I have a positive 10 and a negative 20. So that's going to give me a negative 10 minus 4x. Alright, so now I have x and constant values on both sides. It doesn't matter which side we move them to, just pick one, move your x value to one side, move your constant to the other. So I'm going to say plus 4x plus 4x so I have 11x minus 21 equals negative 10. And to get the 11x by itself, I need to move the constant over to the right side. So I'm adding 21 to both sides. That's 11x equals 11. Divide both sides by 11. And I get x equals 1. Alright. I'm going to check this one just to show you. It doesn't matter if you have fractions, you can still check the problem. So I'm going to plug a positive 1 in up here. I'm not going to have this 28 on the outside. I'm just going to plug it in for every x in my equation. So 1 minus 3 over 4 equals 5 over 14 minus 1 plus 5 over 7. So that's going to be negative 2 over 4 equals 5 over 14 minus 6 over 7. So you can see that this fraction will reduce to negative 1/2. So I have negative 1/2 equals 5 over 14 minus 6 over 7. Now what I'm going to do is I'm going to get a common denominator for all of these terms. Okay, so my common denominator would be 14. And the way that you get the numerator, notice I went ahead and brought down all the signs, all the negative signs. You say 14 divided by 2, that's 7. 7 times 1 is 7. 14 divided by 14 is 1. 1 times 5 is 5. 14 divided by 7 is 2. 2 times 6 is 12. Alright? And so when I work out this right side here, now I have negative 7/14 equals negative 7/14, or negative 1/2 equals negative 1/2. I really didn't have to change this 1/2 back, but I did so that we would have the same denominator. So as long as I have the same thing on both sides, that means that I got the problem right. So the answer is x equals 1. Alright, so that is linear equations with fractions. Now notice with all of our fractions there, they've all been real numbers or constants. If we have variables in the denominators, then we call that a rational equation. Okay, and we can solve rational equations. The only thing is, if I have a variable in the denominator, then I have to be careful that whatever x is equal to doesn't, when I plug it back in, does not give me a 0 in the denominator. Okay, so with rational equations, so how these will be different is that I will have variables in denominators. For example, let's say that I had (3x) over x minus 3 equals 9 over x minus 3 plus 27. Alright, so I need to look at the first thing before I start working anything out. I need to look at all of the denominators. Now in this problem, I have two denominators, but they are the same denominator. So really I only have to look at one of them. And I need to figure out or say to myself, what would x have to be so that my denominator would equal 0? Now, if you're really good with mental math, then you can probably just plug in, you can say, does it need to be a 3? Does it need to be a negative 3? Well, if x is a positive 3, then you'd have 3 minus 3 in either denominator, which is bad. We can't divide by 0. Okay, so 3 minus 3 is 0. Every time we divide by 0, we create a black hole, so we can't do that. All right. Now, if you can't do the mental math, if you like to write down steps, and that is fine by me. The way that you can tell what will make the denominator equal 0, over to the side, just say x minus 3 equals 0, because we want to know when will that be 0. When will x minus 3 equal 0? And then just solve for x. So you see I get x equals 3. So either do it mentally or write it over to the side and figure it out. Now, so what that means is, and this is the first thing that you need to do when working this type of problem, that means that I have a restriction. It's called a restriction because this is something that my answer cannot be. So the first thing that I do is I write down x cannot be equal to a positive 3. That is a restriction on the domain. I know we haven't went over range and domain yet, but that is a restriction on the domain, meaning that something that our x value cannot be. If we work out this problem, and I'll show you how to do that in just a second, but if we work out this problem and we get 3, that means that the answer is no solution. All right. We cannot get a positive 3 for the answer. Now, in a way, we're going to do the same thing on this problem that we did on the previous few problems with fractions. We're going to get a common denominator, the least common denominator, and we're going to multiply it times that entire equation. All right. So what I need to do is I need to look at all of the denominators. Now, with denominators that have more than one term like this, x minus 3, we think about that x minus 3 like that's one term, and we need to take that term. We need to take an x minus 3 as part of our least common denominator. Now, on this problem, it just so happens that I have the same denominator here, and then this last term has no denominator. So when we figure out our least common denominator, we need to always take one of every denominator. Okay, so x minus 3, and then no denominator. So we need to take x minus 3, and that's going to be our least common denominator. That's what I want to multiply every term by. Now, the way that I like to do this is I like to write it all out, just like I did on the previous problems. All right, so if I write this all out, I don't skip any steps, I'm going to have x minus 3 times 3x all over x minus 3. So I'm multiplying x minus 3 times the first term equals, now you can write the x minus 3 in front of the denominator, in front of the numerator or behind the numerator, as long as you put the previous numerator in parentheses. So I'll just write it in front just to be different. Usually we write it the other way around. But x minus 3 times 9 over x minus 3. And then I have a plus And then x minus 3 times what? 27. Again, what have I done? The first thing that I do is I look at each denominator separately and I figure out what would make that denominator equal to 0. The things that would make that denominator equal to 0 are restrictions. Okay? And so once I figure out what x cannot equal to, then I need to get a least common denominator. So I figured out my least common denominator was x minus 3. So multiply x minus 3 times the entire equation. And now, just like with the previous problems with the linear equations with fractions, this is where all the denominators should go away. If they don't, then we did not figure out our least common denominator correctly. Okay? So this x minus 3 in the denominator and this x minus 3 in the numerator cancel out. Same here. The denominator and this term in the numerator cancel out. Now, this last term did not have a denominator, so I'm just going to have to multiply or distribute that 27 to everything inside the parentheses. Alright, so let's see what we have. 3x equals 9 plus, distribute this 27 to everything inside the parentheses. It's okay to write the 27 in the front as well. You don't have to write it behind like I did. I just did it to do something different. Alright, so this is going to be plus 27 times x is 27x. And then 27 times negative 3, that's going to be negative 71. 81, sorry. Negative 81. Alright, so on the right side of this equation, so you have two like terms. So I'm going to combine those two like terms. So that'll be negative 72. Okay. Now I'm going to move all of my x values to one side. Alright, so I'm going to take this x value here, and I'm going to move it over to the left side. So I'm going to have to say minus 27x, minus 27x. So I have 3x minus 27x. That's going to be a negative 24x equals negative 72. Get x by itself, I divide both sides by negative 24. Alright, and so I get x equals, what's negative 72 divided by negative 24? Positive 3. But wait. At the very beginning of the problem, we figured out that x cannot be equal to a positive 3. Because if it is, then bad things happen. Okay? So that means that x is not equal to 3. Alright? The answer is no solution. Alright? If you wanted to, or if this was written out as the solution set is, you could say the solution set is, and this right here, this symbol, that means the empty set. Alright, that basically means no solution. There's no solution, which we can call the empty set. Any questions? So anytime that we work out a rational equation and our answer is one of the restrictions, if we have more than one, or if we just have one, if our answer is one of those, then the answer is no solution. So the solution set is actually this symbol right here. We can say the empty set. Still means no solution. Another good problem. Let's say I had 3 over x plus 6 plus 1 over x minus 2 equals 4 over x squared plus 4x minus 12. So this is the first time we've seen an x squared term. Now when you have an x squared, then that means that you have a quadratic equation, and that quadratic may factor. Anytime any of your denominators will factor, you need to factor them. So even if it was just pulling out a constant or just an x or whatever, do whatever factoring techniques that you've been taught. So I'm going to rewrite this problem. This is 3 over x plus 6. The x plus 6 won't factor. 1 plus 1 over x minus 2. X minus 2 will not factor. But this denominator here, this x squared plus 4x minus 12, that will factor. Okay? And a lot of times, if a problem throws a quadratic into your problem, this type of problem, it's going to factor. So let's see how that would factor. We need x and x. And now look at this last number. It's a negative 12. So the ways that you can get a negative 12 would be, you could say 1 times 12. Of course, one of those would have to be negative and one would have to be positive. You could say 2 times 6. You could say 3 times 4. You know, and it works the other way too. You know, 12 times 1, 6 times 2, 4 times 3. One of those has to be negative, one of those has to be positive. Well, since this was a 1x squared, when we add the two numbers together, we want to get a positive 4. When we multiply the two numbers together, we want to get a negative 12. Alright, so the only combination I could get a positive 4 out of was if this was a positive 6 and this was a negative 2. Then if I multiply those together, I get a negative 12. If I add those two together, I get a positive 4. So that's how that factors. So it's going to be x minus 2 times x plus 6. Okay. Now that I have everything completely factored, or at least I have all of my denominators factored, I need to look at all of the denominators. Okay. We want to think of x plus 6 like it's its own term. We want to think of x minus 2 like it's its own term. And then you see I have these repeated here. I have an x minus 2 and an x plus 6 repeated. So I have to take an x plus 6 for my common denominator. I have to take an x minus 2 for my common denominator. I've already taken an x minus 2 and I've already taken an x plus 6, so I don't take them again. Alright, and so now that I have all the terms that's in my least common denominator, I need to just write the product of all those terms. And that's what I'm going to multiply every term by. So I'm going to multiply every term by x plus 6, and I'm going to multiply every term by x minus 2. Now before I get too far into this, I did not figure out the restrictions. So let's see if we can use mental math and figure out what do I not want my equation to equal to before I multiply all that in. So if you look at the denominators, you can just see if x was a negative 6, that would make this first denominator 0. If x is a positive 2 for this second denominator, that would make that 0. And so if you go to this third denominator, if either of those occur, if x equals 2 or if x equals negative 6, I have problems. So I'm just going to write down the restriction to the side before I forget. X cannot be equal to a positive 2 or a negative 6. So that's my restrictions. Now, what I want to do now is I want to take this least common denominator right here, and I want to write it in each numerator. That means I'm going to multiply it times each numerator. Alright, so I have 3 times x plus 6 times x minus 2 over x plus 6. And plus, now this one is a 1, so I don't have to write my 1 again because I'm multiplying this times 1. So that's going to be x plus 6 times x minus 2 over x minus 2 equals 4 times x plus 6 times x minus 2 over x minus 2 times x plus 6. So I like to write all those out, that way I don't mess anything up. Do I have to? No, I've been doing this long enough where I don't have to, but I would suggest that you do write it out and not you try to use mental math so you don't mess anything up. Alright, so what cancels out? The x plus 6 and the x plus 6. They're the same term, and they cancel out. The x minus 2 and the x minus 2 cancel out. Look at this last one here. X minus 2, x minus 2, x plus 6, x plus 6. All of those cancel out, and just leave me with that 4. So I have 3 times x minus 2 plus x plus 6. Now since this was a plus and it was only this thing in parentheses left over, I dropped the parentheses. If that would have been a minus, I would need to keep it in parentheses. So equals 4. Alright, so now we've gotten rid of all the denominators and the problem becomes a lot easier. Distribute, combine like terms on the same side of the equation. So that's 4x, and then the negative 6 and the positive 6 cancel out. Divide both sides by 4, and I get x equals 1. So we need to compare that answer back to our restrictions. Our restrictions, things x cannot be, were 2 and negative 6. Well, we got x equals a positive 1. So that means that we got something different, so the answer or the solution set is positive 1. Alright. Now the tricky part sometimes is getting the least common denominator. Depending on the problem, that's what usually gives students the most fits, is what is the least common denominator, because they may not factor correctly. We really need to make sure that we remember how to factor quadratics, how to factor out common terms, stuff like that. So you may want to review yourself over some of that if you are having problems with the factoring. See if you can do this one. 1 over x plus 4 plus 1 over x minus 4 equals 22 over x squared minus 16. Alright, so I factored the denominator that would factor. Then I figured out the restrictions, the things that would make these denominators equal to 0. That's a negative 4 and a positive 4. Then I looked at all of the denominators so that I could get the least common denominator. And that's what I'm going to multiply times each term. So that's what I've done here. I multiplied it times each term. Now I need to cancel like terms out. So this and this will cancel out. This and this will cancel out. Those cancel out. Those cancel out. I'm left with x minus 4 plus x plus 4. Since this was a plus and this was the only thing left, I dropped the parentheses. Equals 22. So now add your x values together. Your constants cancel each other out, negative 4 and positive 4. Divide both sides by 2 to get x by itself, so I get x equals 11. Alright, and so check that back with your restrictions. It's not one of your restrictions, so that is my solution. X equals 11, or the solution set is 11. Alright, I want to look at one more of these real quick. These sometimes are considered maybe the easier of the rational equations, but I haven't worked one out. Just want to make sure that you get this down pat. Let's say I have 5 over x equals 10 over 3x plus 4. All of the denominators we've looked at that have variables, they had more than one term. Well, if you just have an x or just have a number times x, the way that you make the denominator equal to 0 is if x is equal to 0. That's the only way if you're not adding or subtracting anything. So the first thing you need to do is write down the restriction, x cannot be equal to 0. Alright, x cannot be equal to 0, because if it was 0, it would make either one of these denominators 0. Now, when we find the least common denominator, we need to be careful. I know that we have x to the first here and x to the first here, but we have a 3 in front here, and so we can't leave something out. That means that this 3 also has to go with our least common denominator. Alright, so since I'm multiplying 3 times the x in this one, I have to take that 3. So my least common denominator is going to be x to the first and times 3. So it's just going to be 3x. Cannot leave the 3 out. And then this doesn't have a denominator, so it doesn't say anything. It doesn't tell us anything. Alright, so now multiply 3x times each term. So that's going to be 15x over x equals 30x over 3x plus 3x times 4 is 12x. Now, if you want to just write the 3x in parentheses beside each one, you can. I just went ahead and multiplied them in. Either way will be fine. Either way, you'll get the right answer if you multiply correctly. Alright, so the the x's cancel out with the first term. The x's cancel out with the second term. And also, I have a 30 up top and a 3 on the bottom, so you can divide that by 3 and divide that by 3 and get 10. And then I have plus 12x. So what am I left with? 15 equals 10 plus 12x. Alright, so this is one of those when I'm probably not going to move my x to the left side because it's already on the right side and there's no other x over here. So I'm going to take the 10 and move it over. So that will be minus 10 on both sides. So leaves me with 5. So 5 equals 12x. Divide both sides by 12 because that's what's beside the x. And so my solution is x equals 5 over 12. So compare that to your restriction. Alright, and it's not the restriction, so that's the solution. Alright, the last topic that we are going to cover in this section is whether an equation is an identity, a conditional equation, or an inconsistent equation. Okay, so we have three different possibilities for an equation. Either we have an identity, we have a conditional equation, well, I'll just say conditional, or an inconsistent equation. Alright. An equation is an identity if for every real number that we plug in, both sides of the equation are equal. So that would be something like, let's say I had 2x plus 1 equals x plus x plus 1. Okay? For any value you plug in for x, as long as you plug it in everywhere, any number, any real number, both sides of the equation will always be equal. That's because you could simplify the right side of the equation and say x plus x is 2x. And so if you have the same thing on both sides of the equation, then that's going to be an identity. Okay? So if you can plug in a number, any number, into an equation for every x, and you always get the same thing on both sides, that's called an identity. Now, what happens if you have an equation and you start working it out and the x values cancel out? Like on this problem, if I would have been given this, solve the equation, I would have 2x plus 1 equals 2x plus 1, and then I would try to move the variable over, and you see really quick that the variable cancels out and just leaves you with 1 equals 1. So if you're working out an equation, your x values cancel out and you're just left with the same thing on both sides, then that's an identity as well. That's one way to tell. because sometimes it's not going to be as apparent as this right here, that you can just tell the same thing is on both sides. So what happens is you start working out the problem, and then the variables cancel out, and you're left with a constant equals a constant, and it's the same constant on both sides. Well, that's an identity. Okay. Now, if you start working out stuff and your x values cancel out and the numbers are different on both sides. So, for example, if you have x plus 4 equals x minus 2. Now, you wouldn't have something this simple probably, but if this was your equation and you started working it out trying to solve for x and you moved x over and the x's canceled out and you were left with 4 equals negative 2, 4 is not equal to negative 2. Okay? That means that this is an inconsistent equation. So you start working things out, the variables cancel out, and you have a constant equals a constant, and they're different. You get a false statement. That's an inconsistent equation. That means that it doesn't matter what you plug in, you're never going to get the same thing on both sides of the equation. You go back up here to the original equation. It doesn't matter what you plug in, you can never get the same thing on both sides of the equation. So it's an identity if it will work for any value of x, or you get the same constant on both sides. It's an inconsistent equation if no matter what you plug in for x, you can't get the same thing on both sides, or if you have a constant on each side and they're different. The last type of equation is the type we have been working out in here pretty much all day. It is if you can solve for x and get a value for x, and it's not a restriction or anything, that's called a conditional equation. That means the equation is true as long as x is equal to whatever you found it to be equal to. So whether you knew it or not, the majority of the equations that you've been working in here so far have been conditional equations. So like if I have 2x plus 1 equals 9, and I can solve it and get an answer out, so 2x equals 8, or x equals 4, I get an answer. That's a conditional equation because that equation will be true when x is equal to 4. So a lot of your homework problems, they'll have you work it out and then ask you what type of equation is it. So if it will work for all real numbers, or you get a true statement, that's an identity. If your variables cancel out and you get a false statement, that's an inconsistent equation. If you get out an answer, if you can solve the equation and you get out an answer, it's a conditional equation. So if I had to guess, I would say the majority of your homework will probably be conditional equations.